Now you might be thinking to yourself, why do we even need standard form? What's it good for? Here's where that's going to come into play. So in this example, we need to find the x-intercept and the y-intercept of the graph 2x minus 3y plus 8 equals 0, and then we're going to sketch a graph of that equation. So first, I'm going to put this in standard form. So I need to move the 8 over to the other side by subtracting it. So we've got 2x minus 3y equals negative 8. When we're finding the x-intercept and the y-intercept, it's very, very useful to have our equation in standard form. And that's because an x-intercept is where y is equal to 0. So if y were equal to 0, we could plug that in here and say, okay, what is negative 3 times 0? Well, that's just 0. So then we have 2x equal to negative 8. If you're doing this on a piece of paper, you could literally just cover up that negative 3y if you're looking for the x-intercept. So we have 2x equals negative 8, and then we're going to divide by 2, so x is equal to negative 4. So then our x-intercept is at the point negative 4, 0, and we can plot that point, negative 4, 0, there's our x-intercept. If we're looking for the y-intercept, we can do the exact same thing, but cover up our x. So a y-intercept is where x is equal to 0. If we were to plug in 0 for x here, we would have 2 times 0, which is still just 0. So all that we're left with is negative 3y equals negative 8. Then to get y by itself, we would divide by negative 3. So y is equal to 8 over 3, which is 2 2/3. So then we have the point 0, because that was our x value, and 8 over 3. The reason I said 2 2/3 is because that's going to be easier for me to graph. If you can look at a graph and know where 8 over 3 is, great. So then now we've got 0 and up 2 2/3. There is our other point. And now we can graph our line through those 2 points. And there's a rough sketch of this graph.